Hi, I'm Oyewale Olatunbosun. I'm here to present to you a tutorial on differential calculus. I really wanted to show you some shortcut methods of differentiating power functions today. Let's go straight to example 3. We have been working on various examples. This number 3 example, differentiate 1 over 5 root x. Now, let's see. You can see at the denominator we have 5 root x. That's a radical. Now, do we do that? We have to change, we do slight manipulation, mathematical manipulations here. Now, 1 over 5 root x becomes 1 over 5 x raised to the power half. Of course, I believe you know from sort or indices that root x is x raised to the power half. So that is cool. Now we go further and change, because our goal is to obtain power form of the equations so as to facilitate our differentiating, our process of differentiation. Now, when this x power half moves up, it becomes x raised to the power minus half. So now we have what? 1 over 5 of x raised to the power minus half. So we bring this constant. That is very easy now to differentiate. What we do now next is move this constant out, then obtain the derivative of this in a bracket. So that means minus half will come forward, then x raised to the power minus half minus 1. Remember, in differentiation, the old power will come forward, then the new power will be equal to old power again minus what? 1. So that is minus half minus 1. And when we subtract 1 from half minus half, we have minus 3 over 2. So that's the new power. Then we multiply 1 over 5 by minus half, we have minus 1 over 10. So we have minus 10 minus 1 over 10 x raised to the power minus 3 over 2. Now coming down, we have minus 1 over 10. Change this x raised to the power minus 3 over 2 now to positive power. We have 1 over x raised to the power 3 over 2 in the bracket. So we can also change this again to radical. That becomes root x raised to the power 3. So that is minus 1 times 1, that's minus 1. 10 times root x raised to the power 3 becomes 10 root x. That is indices at work. You can see how we apply indices at every stage. Now look at the laws of indices that we actually applied. X raised to the power minus a over b is equal to 1 over x raised to the power a over b, or is equal to 1 over b root x raised to the power a. And you know that x raised to the power a over 2 is also what? Root x raised to the power a. Those are the laws of indices applied that give us our final result for the derivative of 1 over 5 root x. Right? So let's go to the next example and see what we have to solve again. We have y equals to 1 over 10x, and we are required to obtain the derivative of that. And let's see, how do we solve? How do we differentiate function of this nature? What can we do to obtain the derivative of this? Wow. We really need to understand that 1 over 10x is the same thing as 1 over 10 times 1 over x. And you know that 1 over x is x raised to the power minus 1 in indices. So we have 1 over 10 times x raised to the power minus 1. Now that makes our work very easy now. We can bring this 1 over 10 out, then obtain the derivative of x raised to the power minus 1, which is very easy. Minus 1 goes forward. That's minus 1 multiplying x. Then the whole power, which was minus 1, becomes minus 1. Then we subtract 1 from it, minus 1 again. So that means minus 1 is the new power. You must always subtract 1 from the old power to get the new power. So that is what? X raised to the power minus 2 inside the bracket. And I multiply that by 1 over 10, and that gives us what? Minus 1 over 10. No, minus times 1 is what? Minus 1. So minus 1 over 10, x raised to the power minus 2. And we know that x raised to the power minus 2 is what? 1 over x squared. So that is what we got here. So our answer actually is what? Minus 1 over 10 squared. We have applied some laws of indices, which you have seen here. X raised to the power minus 1 is equal to 1 over x. All right, and x to the power minus 2 is what? 1 over x squared. That's all that we have to go through for today. And I will invite you to always join us for more video tutorials. Thank you very much.